Hello, today we're going to review factoring polynomial expressions and a little bit of review on multiplying. So as you can see here, we have a table that we're going to use as a modeling tool to assist in multiplying the quantity x plus 7 times quantity x plus 3. And the first thing I might add is that this year in our class, we've been writing the binomial on the other side. And because this is representing a rectangle, we know that both opposite sides are equivalent. And we do this because of the way we use the tabular method to add diagonally. And so your result here is x squared plus 3x plus 7x plus 21. And your final answer is x squared plus 10x plus 21. And what I'd like to remind you is exactly how we got each term. And the 10x came from the sum of 3x and 7x. So we'll write sum there. And the 21 came from the product of 7 and 3. And for the moment, this is important for us to get the final answer, but it really becomes important for us when we start to undo, when we start to reverse this process, and we start looking at the trinomial and trying to figure out what two binomials created it. And just as a reminder, what this table represents, each cell within the table represents the product of the number along the length and width. So that's just kind of a reminder or review on exactly what the table helps us do. So again, we have review. Review says use a table to aid in finding the product of the quantity 2x plus 1 times quantity x plus 4. And again, we can use a table. (2x plus 1, x plus 4). The length and the width can be interchangeable because it is multiplication and we have the commutative property. And so I look at this and I like to start in this top left-hand corner. So I have 2x times x gives me 2x squared. 1 times x, and I put the sign in there just to remind myself, 1x. 2x times positive 4 is positive 8x. And 1 times 4 is positive 4. I can sum down the diagonal, and so I get 2x squared, 9x, and 4. And the product is 2x squared plus 9x plus 4. Reminding ourselves that the 9x came from the sum of two numbers, and the 4 came as a product. These at the moment are really important, especially when we get to reversing this and beginning our factoring. So I have a small definition for you guys. Polynomial expression is either a numerical expression or a variable symbol, or the result of placing two previously generated polynomial expressions into the blanks of the addition operator or the multiplication operator. As a reminder, a blank may be filled with negative numbers or coefficients. So recall that a plus and negative is equivalent to just a negative, or positive times a negative is just negative. So that's how we get this subtraction. So it actually does cover all bases. Okay? And so here we go. The reason why we started with multiplication is so that we had a foundation to which we could sort of reverse it. And as you're looking at the first example, you have x squared plus 8x plus 7, and we're supposed to factor the following quadratic expressions. So factor means to break it into its multiplication pieces. And as a reminder, the 8x was the sum, the 7x was the product. And the reason why I need these numbers are they are the parts that help me figure out what goes into my parentheses. And I'll put the clues together. So I know that x squared came from x times x. Then another clue, this is really important, that because this is a plus 7, that must mean the signs are the same. With the two numbers that were multiplied together to get that product. Then what we want to do is sort of make a list. So you have things that multiply to 7. And again, I add the sign just to make sure I remember it. And add to 8. The only two numbers I can think of that multiply to 7 are 1 and 7 and negative 1 times negative 7. When I add them up, 1 plus 7 equals 8, which is what I want. So I kind of identify that. And negative 1 plus negative 7, which is negative 8, which is not the one I want. And then directly I can put these in there. So that must have been a positive 1 and a positive 7. Now this is a really nice problem because the two endpoints only have a couple ways to multiply to get them. This is a little different when you get to a problem like this. There are lots of ways to multiply to 90. As a reminder, my sum, my product, since the sign is a subtraction of 90, it must have been different signs, a positive times a negative. Again, I'll make my list. So I have product and a sum. I need to multiply to negative 90. I need to add to positive 1. So if I start off my list, I know negative 1 times 90 equals 90, negative 2 times 45 equals 90, negative 90, negative 3 times 30 equals negative 90, negative 5 times 18 equals negative 90, negative 6 times 15 equals 90, negative 9 times 10 equals 90, and then we sort of reverse it. Negative 10 times 9, negative 15 times 6, negative 18 times 5, negative 30 times 3, negative 45 times 2, and negative 90 times 1. As you get more and more practice with this, you won't have to make the list as big because ultimately we need numbers that are subtracted and get very, very close to 1. And so as I'm looking at this, I'll kind of center my work right here. Negative 6 plus 15 is a positive 9. Negative 9 plus 10 equals a positive 1. And that's ultimately the two values that I need. So here I can go m minus 9, m plus 10, and I factor my trinomial. want you to pause, think about what we've done with these more basic problems before we continue on to the more difficult ones. All right. Next problem, there are a couple different ways to do it. You might want to pause and just take some time to read through the directions or the think aloud that's been provided typed out. And I'd like to show you a second method. So I'm going to label it a second method. Still, what I'm going to notice is that this is a prime number. This is my sum. This is my product. And I notice that this is a plus sign, so signs must be the same. What I'm going to do is I'm actually going to multiply, if you think about A being equal to 2 and C being equal to 15 from our standard form. I'm going to multiply 2 times 15, which gives me positive 30. I'm going to make my list based on this positive 30. And then again, the sum is the same term, the positive 13. My list of numbers, 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And we could keep going on with the negative or the opposite numbers of each of those. But what I notice is that 3 plus 10 is equal to 13. Now the question becomes, how do I put these into the parentheses? And I like to start with thinking about the leading coefficient. I know it's a prime number, so its only factors are itself and 1. So I put the 2x and the x. I know that the middle term or the x term is positive. Signs need to be the same, so I can put the plus and the plus. And then ultimately I look at what numbers I have. I have a 3 and a 10. And therefore when I'm looking at this, I need two numbers that multiply to 10. So that'd be 5 times 2. And that'll give me my 10x. And then 3 times x. And so this will sum to 13. Also, 3 times 5 equals 15, which is the thing that we need for the product. And this is the breakdown for some of the more advanced questions. It's time to pause, write a little bit of summary about what you've just seen, areas of concern or complication, so that you can come back and talk to your teachers. There will be a second video giving you 2 more examples of this more difficult kind, posted on YouTube also. Thank you.